Okay, so what we're gonna do is we're gonna talk about the next one, which is physics. Yay. Motions. So in physics, we call it kinematic. In calculus, we're just gonna call it motion. What kind of motion are they? Velocity, acceleration. Now, what happened is in college, right? At least in UF, they have two type of physics class for you guys for future reference. If you go to engineering field, then there is a physics with calc. And if you do a medical field, which is like say, and like you try to study to go to dental school or pharmacy school, you can take physics without calc. So there's a physics with calc and there's a physics without calc. I personally prefer physics with calc just because I think it's a little bit less work, but more you have to understand a little bit more about calculus. So there are two different tracks you can take. You can choose whatever you need to do. Now the code in terms of in UF is a, and in UCF the same thing. It's a physics, which is PHI. 2048 is with the calc, and 2049. So physics with calc is 2048 and 2049. Now physics without calc is 2054 and 2053 and 2054. It doesn't mean 53 and 54 is a higher number, so it's harder. It's actually 2048, 2049 is a higher level course. So now you got position, you got velocity, you got acceleration. So the way I kind of think about the notation for you guys, a lot of time, a lot of people AP exam they use x of t is equal to positions. Okay. But I don't use x of t because I don't think that the particles always travel in the x direction. I usually call it s of t. Now on your AP exam could have been y of t. If something go in the y direction, a ball is shooting up in the air, then maybe y of t, maybe h of t, because t is the x-axis and the h of t is gonna be the y-axis. So it could be that way. So I use s of t, just think about it as a position. So now if I have velocity, it's gonna be s prime of t, or also that's equal to v of t. Okay, so that could be s prime, or I call it v of t. Now this is not any type of velocity. This is actually called instantaneous. This is acceleration, which is in terms of projectile, gravity is acceleration. So negative 32 feet per second or negative 90.8 meter per second. But in terms of everything else, the acceleration might be different, depends on what the situation we get into. So S double prime of t or V prime of t, and that's equal to definitely A of t. So that's that. Now it turns out PVA, it looks like this. From here to here is all derivative. And from here to here is integral. Or antiderivative, to be more precise. Kind of fix up what Derek say. So I can integrate of A of t dt. If I integrate, I'm going to get V of t, but plus c. Because you probably have some type of time and position to find out the c. So that c is kind of relevant. And if I integrate V of t dt, is going to be s of t. So you can integrate that is equal to s of t plus c. So if you integrate V of t, it's going to be like this. Now let's go focus on velocity. there's two type of velocity in general in calculus. What kind of velocity you can think of?
Motion.
Huh? Instantaneous?
Average.
Yeah, good job. Average. Okay. Instantaneous. I have no idea how to spell this. I totally made it up.
Without the T. Get rid of the third T. Get rid of it.
Get rid of the T. I've been spelling right. The instant. It's 2T or 1T?
It's 2.
So, Derek, you just make me. Where's the T?
Yeah, that's good. No. That was 3 T's.
Oh,
It's instantaneous.
like this?
Yes. Yeah.
Okay, so instantaneous, not rate, but is a velocity. Okay, instantaneous velocity, and there is a average velocity. And we both learned this before. We're gonna start with the instantaneous. That's just that's just S prime. That's just gonna be S prime of t, or V of t. Average velocity is gonna be the changing of positions over changing of time. Now, please know this because a lot of people thought average velocity is changing of velocity over changing time, but it's actually changing of positions. So if in term of position, it's going to be SB minus SA over B minus A. It kind of remind you like, that's like average rate of change. Kind of remind you of average rate of change. So yeah, they are the same in this case. Is S of B minus S of A over B minus A. But so far we know all the stuff because we learned it before. Now something we did not learn here, which is I'm gonna write in red, is what if I'm gonna question this, what if the velocity equation is given to you instead of positions? How would you find average velocity from a velocity equations? Any type of velocity. So what if I give you v of t is equal to 2t? How would I find the average velocity if a velocity is given as opposed to position? Yes, Zach? Yeah, but there's something else.
Time is like, take the interval and we need to run.
No, Derek is on the right track. Now he's all embarrassed. He's like, wait, am I on the right track? No, you were right. You were right.
Right, like whatever time is.
Time is what?
This over. Velocity, distance.
It's just B minus A. That's the time period, right? So, do you remember this? This is something that's supposed to be on the last test, but remember, that morning I come in, I was like, my test is on my computer, I'm gonna be ready, so when I turn on my computer, I cannot find the damn test. I was like, shit. And I had to make up a test within very, very short time, like roughly 5 minutes. So that was supposed to be half of your test. So your test supposed to including the question that we just went over the first part, and also supposed to have average value. So remember the average value is 1 over B minus A in the front.
Yes.
And integration between A to B of V of t dt. And if you do this, what will happen? If I integrate V of t, what am I going to get?
B minus
S, right? Does that make sense?
Yep.
And this is times by 1 over B minus A. Does that look familiar? It's the same thing.
That's average value.
Yeah, it's average value. So if you do average value of velocity equation, that's actually average velocity. So that's why I talk about a lot of time that's why I give you a homework question. Like one question is talking about average rate of change. The same question I ask you, what is average value? But in this case, the average rate of change of position is equivalent to average value of a velocity. And they both are average velocity. Does that make sense?
Yeah. Average value of velocity and average velocity.
Okay.
Exactly.
Oh, yeah.
Okay, so now we have talked about average velocity. Now, since we're on the velocity, we have to know the difference between velocity and speed. What can you tell me the major difference between velocity and speed?
Velocity and direction.
Vector.
Yeah,
Scalar.
Oh, guys, remember the second movie one? He's like vector, direction, and magnitude.
What? Well, I'm
You remember the velocity? You remember the velocity?
I did not.
Oh, remember the guy in like the he had an orange. The orange jumpsuit. Yeah, stole the concrete. I know. When he was introducing himself, his name was Vector.
Mrs. Incredible Me?
Yeah.
Despicable Me. Yeah.
Despicable Me. Despicable Me. I don't know. I was thinking about yeah, yeah. I combined both. Yeah. What did it talk about in that movie?
The villain's name was Vector, and then he's like direction and magnitude when he was introducing himself.
Oh, I remember this. It was very funny. It's a very funny story of mine. I remember one year I have this girl in Cyprus, and it's pretty ratchet. That school. So the girl is basically coming, right? That's the first year I was teaching, right? So she coming with like earring, nose ring, chain ring, purple hair, about just as big as like rubber, very very strong, and it's a little bit shorter. Tattoos everywhere, and ride a motorcycle. And then she's such a badass. So she just ride a motorcycle and she just parked behind my portable. And that's like the first day. She just pulled up, parked there, come into class. And the first thing she saw me, she's like, "What the F are you looking at?" I'm like, so it turns out she just come out from juvenile, from selling drugs. But I remember like I can never make this girl smile at all. Like this girl will not smile all day. So one day my wife gave me a haircut. And my wife gave me a haircut is pretty much take a bowl and just cut it around it, right? And so I got this bowl cut and come to school. And I was like, yeah, and also kind of make fun of my haircut. And she laughed for the first time. I said my haircut looked like the Victor from the Despicable Me. And you know Victor, he was like this. And she laughed for the first time. And I thought it was like my major accomplishment that year to make her laugh, because she will never laugh. She literally, she don't want to sit in the front. She have to sit in the back because she was from juvenile. She think like people's gonna jump her because she don't want people to sit behind her. She says that's, and I told the admin says I move her seat to the front because she don't want to change. So, and the admin's like, yeah, just leave her be. she say she don't feel safe when somebody is behind her. That's yeah, it's a very interesting trauma though. But yeah, it was very very interesting because I end up write her recommendation letter for she trying to work at Family Dollar assistant manager, and she come into me. She's like, "Hey, Mister, I need your favor." I was like, "What is it?" And I write her recommendation for her to work in Family Dollar, and she's actually I think pretty established now. But she changed her life around, which is pretty cool. And I really think that's one part. It was pretty funny.
Yeah. She was not
What class
advanced
were you
basic calculus.
No, she was in algebra 2, but she was very good with number because she's selling a lot of merchandise. So if you told her 25 times 5, she'll be like, well, that's 125. That's easy. And she'll be like, yeah. So she was really good at number. That's the funny thing about it. Yeah, she's an entrepreneur. That's she does have an entrepreneur thing. The velocity versus speed. Sorry, I got distracted. So there's a difference between velocity and speed. What's the major difference? Direction. So for example, if I'm driving New York and if we assign north as a positive, so we have to assign north as positive and south is negative. So therefore, if I'm driving to New York, I'm driving 100 miles per hour. I'm just going to be positive 100 miles per hour. But if I drive into Miami, it's no longer positive 100 miles per hour because I'm driving south, so it's going to be negative 100 miles per hour. But speed doesn't give crap about if you driving north or south, so it's going to be absolute value. So speed is equal to absolute value of v of t, and that's it. So because you make everything positive. Okay, so that's a speed. Now, once we talk about speed, everything else is gonna falling in line. Is the total distance, total displacement versus total distance. So there are two type of question on AP exam. They can ask you total displacement, they can ask you total distance, and you want to figure out what is what. So what's the major difference between total displacement and total distance?
Displacement is just like
Basil?
how far you are from the starting point. It's like overall, and distance is just like how far you've gone over the entire courses and
Okay, so for example, like that's exactly what you say. What if I'm right here and I go around the room and come back to the same position? My total displacement is going to be 0.
I thought it was the opposite.
No, total displacement is going to be 0. So because total displacement is equal to integration between a and b of v of t dt, and that's equal to s of b minus s of a. It just doesn't have the time, didn't divide it by time. It just had a final position minus the initial positions. And that's it. And that's a total displacement. So my final position is at this C. My initial position is this C. So it'll be 0 minus 0. Or if I assign this to position 2, then it'll be 2 minus 2. So it'll still be 0. But if I have total distance, it's all the distance around the classroom. So I need to go back and measure all around classroom. Okay. I did miss something that we talked about before, so I'm going to go back to talk about something else. A lot of people thought average velocity is this equation, but it's not. This is called average acceleration. And a lot of people get confused with that. It's actually v of b minus v of a over b minus a. Because if I find out the difference between velocity over time, that's actually the slope of velocity. Slope of velocity is actually acceleration. But a lot of people, when I ask them average velocity, they did this. But that's wrong, because average acceleration is v of b minus v of a over b minus a. So what you find is average acceleration as opposed to average velocity. Average velocity is changing position over changing time. Don't get confused. These two are completely different. So make sure that they understand there is a small difference. Now, this one's SB minus SA. Then you say, okay, that makes sense. But what's total? What is the total? This distance. Which is, that's a one common question they love to ask. They love to ask this too. And they love to ask total distance even more. And they do ask B. They do ask the average velocity, and they do ask instantaneous velocity. They do ask a lot of those. So on AP exam, but they do love ask total distance in the things. Now, let me give you an example of me on a number line. And this is position 0. If I take one step forward, like say 1 meter in 1 second, right? In 1 second. And let's say at second I take a step backwards. What is my displacement? 0. Good. So it's 0. But what's my total distance? 2. So, and let me give you some analogy in terms of graphing. So let's translate that to velocity versus time graph. And if you want to change that to that, I'm going to show you what happened. What do you think the graph look like? This one's kind of hard to figure out what the graph look like. If I just assume that I have the same speed the whole time in 1 second, right? What would be the graph? Or in those 2 seconds, I'm going to have the same speed throughout. Yes. It's not vertical, no.
It's just like a triangle.
No, it's not a triangle either.
Is it like a diagonal line, like downwards?
Nope, it's not that.
You're saying like it'd be a horizontal line, right? If you're maintaining the same speed the entire time.
Yeah.
But they need to slow down.
So you think it's what?
Well, you said you're like even when you turn around, you still are somehow maintaining the same speed.
Yep.
Oh.
Well, that would be a horizontal line.
With
Yes and no. Ethan?
The first chart would be a constant line above the x-axis, and then the second part would be a constant line below the x-axis.
Exactly. So you'll look like this because I have a constant positive velocity and I have a constant negative velocity, right? And let's see if I think that makes sense. Because if I have this part is the positive and this part is the negative. And if you are displacement, it's just integration between 0 to 2, then the positive and negative, they kind of cancel out each other. And in this case, would have been 0. Does that make sense in this situation? Same situations. Now, what do you think the total distance is equation is?
1 plus 1.
No.
Absolute value
theta a plus
absolute value x equals 2. Or y equals 2. I don't know.
You're on the right track. What?
No, wait, okay, so it's the integral from 0 to 4.
Not 0 to 4. We could talk about any intervals. It's going to be A and B. Okay, what else? Hold on. Oh, unless you want to give it a right to him. Go ahead.
Absolute value of u dt.
Yep. Why is absolute value though? If you think about this absolute value, you're gonna make this graph above, right? So guess what? I got 2. Makes sense. Right? So does that make sense? So that if I absolute value of v of t, if I integrate it, so that I'm gonna make it a velocity graph, there's no negative value. It's always positive. So whatever area under the curve, it's gonna be my total distance traveled. Now here's my question. Now this question is not gonna test on AP exam. It tests you if you understand what I say. Is this a true statement?
Probably. Maybe not.
And if it's true, why? If it's a false, why? Because some student asked me this, and I had to think about it, and I had to think about this. Is this a true? It's true or false?
False. Well, why would it be? Well, there had to be an over b minus a, so it's false, right?
No, I would think that's true.
Wouldn't it be
Oh, yeah.
So that's a B. Big has to be minus big.
True or false?
It's true.
The answer is false. The reason being is, shh, if you think about it, this is the initial position. In the term of here, my initial position is a 0. And my final position is still 0. So 0 minus 0, absolute value of 0 is still 0. So in term of this, is not the total distance. It's actually the absolute value of a total displacement, which is the total displacement could be 0. So it's not really the total distance. Does that make sense?
You're subtracting them and then you're doing that.
Yeah, and that's like you just absolute value total displacement is not the same as total dis. So even like small things like this is like really see if you're really understanding about physics.